what if the reason your smart home keeps dropping offline has like nothing to do with your Wi-Fi router?
Right.
And it has absolutely everything to do with a factory in China misunderstanding a radio frequency protocol.
It happens way more than people think.
Yeah. So today we're going to look at how placing an antenna, just 1 millimeter too close to a power supply during the manufacturing phase can just completely sabotage your mesh network.
Yeah.
But I think more importantly, we're looking at what happens when the ambition of smart home platforms completely outpaces the actual reality of the hardware they're running on.
Well, yeah, I mean, we are seeing a profound fracture in the industry right now. On one side, you've got these ecosystem players rushing to make our homes, hyper-aware.
Right.
They're deploying ambient sensing and generative AI to predict basically our every move. But on the exact same timeline, the foundational hardware, the sensors, the switches, the routing nodes that actually execute these commands, well, they're struggling with basic fundamental reliability.
Yeah, it's a mess. So welcome to this week's episode of Smart Home News. Our mission today is to dissect that exact tension.
Mm-hmm.
We're looking at Comcast attempting to turn your standard internet router into an invisible motion sensor.
That's a big one.
Right. And why Google's advanced AI completely forgot people's bets this week. Plus, we'll get into the deeply mechanical reasons why building a truly reliable Z-Wave device is actually, an incredibly difficult craft.
Yeah, it is a critical week for anyone paying attention to ecosystem strategy, because navigating this space right now requires a very sharp eye to separate, durable long-term engineering from just short-term software hype.
Totally. So let's start right there with the push for ambient data collection. This week, Comcast announced a new platform called Xfinity Shield.
Right.
And a major component of this rollout is this opt-in service called Wi-Fi Motion.
Yeah.
And the premise is that it takes the least Comcast gateway, like the literal box currently sitting in your living room providing your internet, and it transforms it into a full-blown motion sensing device.
Yeah, the mechanism behind this is genuinely fascinating from just a physics standpoint. I mean, we are not talking about a traditional passive infrared or PIR sensor that detects heat signatures.
Right, like those little white domes in the corner of a room.
Exactly. This relies on channel state information, or CSI, within the actual Wi-Fi protocol. So essentially, your router is constantly broadcasting radio waves on the 2.4 and 5 gigahertz bands.
Just to keep your phone connected and stuff.
Right. And those waves, they bounce off your walls, they bounce off your couch, your kitchen cabinets, and they establish a baseline map of the radio frequency environment in your house.
And because humans are, essentially just giant bags of water walking around the house, we disrupt those radio waves.
Yeah, exactly. We're just walking water. So when you walk through a room, you absorb and scatter those signals, and that creates what's called multipath distortion.
Okay.
So the router actually measures the micro changes in how long the signals take to bounce back to it, processes that interference, and then registers it as physical motion.
Wow. So on a purely technical level, it is brilliant.
Oh, yeah.
I mean, you get motion detection across an entire floor plan without buying a single battery-powered sensor. And isn't convenience like the ultimate goal of the smart home? To have things just work without us maintaining 50 different endpoints.
I mean, ideally, sure.
Right. I can see a massive segment of the consumer market loving a zero-friction security upgrade that just requires, flipping a switch in and out.
Well, the convenience is undeniable, but it introduces a massive shift in how we define a network appliance.
How so?
Well, historically, the ISP's router was just a dumb pipe, right? It brought data in, it brought data out. Now, they're attempting to turn the physical infrastructure of your home into an active environmental monitor. And that transition it comes with a heavy baggage regarding data ownership.
Yeah, which brings us to the user reaction this week. If you look at the smart home community, particularly on platforms like Reddit, the pushback was intense.
Oh, I bet.
Yeah. Users were specifically pointing to a clause in the Xfinity Shield support documentation. And it states that Comcast might share this motion sensing data without notifying the user if they are legally compelled to do so.
Wow.
Right. Now, we aren't here to judge Comcast's specific corporate policies, but objectively, this changes the dynamic of trusting your ISP. It's kind of like renting an apartment where the landlord suddenly announces that the walls can track your movement,
Right.
but they market it to you as a security upgrade.
Yeah, it absolutely alters the calculus for the consumer. When you rely on a cloud-tethered ISP gateway for ambient sensing, you are inherently renting your environmental data.
Renting it.
The platform decides how it's processed, where it's stored, and who gets access to it.
And that's exactly why I think announcements like this inadvertently act as like the best possible marketing for local control ecosystems.
Oh, 100%.
Because if you take the time to set up Home Assistant and you deploy a local Zigbee motion sensor, that packet of data stays on your hub. It literally never leaves your drywall. So at what point does the average consumer look at things like Wi-Fi motion and decide the learning curve of a local Zigbee network is actually worth it, just to retain ownership of their family's movement data?
I think we are seeing that inflection point right now. As cloud platforms push further into this passive surveillance, the friction of learning a local open source system suddenly feels like a very reasonable defense mechanism.
Yeah.
The trade-off for absolute convenience is absolute visibility.
So Comcast is illustrating this intense industry obsession with gathering ambient data. But capturing that data, like registering that a physical body moved through a room, is really only half the battle.
Right. They have to know what to do with it.
Exactly. The platforms actually have to interpret what that data means. And that brings us to this massive and honestly often clumsy injection of generative AI into the home that we saw this week.
The AI rollout is accelerating fast, and the results are incredibly polarizing, mostly depending on the environment you deploy it in.
Right. So Amazon made a huge push here. They announced they're making Alexa Plus available to a much broader audience, specifically U.S. Fire TV owners, completely for free.
Okay.
This includes the Fire TV Stick, the Cube, Amazon Ember Smart TVs, and even third-party models from Panasonic and Hisense.
Nice.
Yeah, previously, getting this conversational AI required a subscription. Now it's within everyone's reach. So you can ask the TV to find movies based on a highly specific mood, or jump to precise scenes, or even answer questions about the actors currently on screen.
And this is a scenario where large language models, or LLMs, actually thrive.
Really? Why there specifically?
Well, when you use generative AI in a media consumption environment, the AI is interfacing with structured digital metadata.
Okay.
So it's reading JSON files, video tags, genre classifications, closed caption transcripts. It exists in a perfectly controlled digital sandbox.
Oh, I see.
Yeah. So if you ask for a lighthearted 90s heist movie, the LLM just matches and synthesizes those highly structured text tags. It's not guessing.
Right. So it's impressive, but it's fundamentally just a really advanced search query.
Exactly.
Where this completely falls apart is when you try to take that same generative AI and apply it to the unstructured, messy chaos of a physical living room.
Oh, yeah. Which brings us to Google's attempt this week to integrate Gemini into physical home monitoring.
Right. So Google pushed a feature for Gemini for Home called Pet Memory.
Yep.
And the pitch was that your connected Nest cameras wouldn't just give you a generic animal detected alert. The AI was actually supposed to learn the specific identity of your pets.
Right. So it would distinguish between your golden retriever, your neighbor's cat, maybe a random squirrel in the yard.
Yeah, exactly. Allowing you to trigger specific automations based on exactly which animal walked by.
The ambition is clear, but the technical reality of computer vision in an uncontrolled environment is brutal.
Yeah.
I mean, basic object detection, like drawing a bounding box around a dog, that's mature technology. But specific facial and physical recognition of moving animals requires processing an absurd number of variables.
And the execution absolutely face-planted.
Did it?
Oh, yeah. We saw reports from users testing the beta where the AI literally forgot who their cats were.
Oh, no.
Yeah. After a few days, it just stopped recognizing the specific animals it was marketed to track.
See, that's because a physical home is hostile to AI models.
Hostile? Like how?
Well, think about it. The lighting changes every hour based on the sun.
Right.
The cat curls up in some weird, unidentifiable shape. A shadow falls across the rug at 4 p.m. and completely distorts the contrast. Generative AI hallucinates and struggles when it can't rely on clean, structured data.
Okay, let me play devil's advocate for a second.
Sure.
Is it possible we're being too harsh on Google here? I mean, yes, the AI forgot the cat today and it feels like a failure. But isn't exposing these machine learning models to the messy real world the only way they eventually learn?
Well, yes.
Right. Don't they have to train on these chaotic edge cases to eventually replace rigid binary motion sensors?
That is the long-term engineering argument, absolutely. The models will only improve through real-world exposure. Right.
But we have to look at the immediate impact on the smart home user today. When an ecosystem uses its customer base to beta test a core feature, and that feature fails, It introduces massive friction.
Yeah, that's fair.
I mean, a simple, dumb, locally processed motion sensor that triggers 100% of the time is infinitely more valuable to a user today than a brilliant cloud AI that gets confused by a shadow and breaks your automation.
It just highlights the difference between software ambition and hardware reality. When the AI fails, we realize how much we actually rely on the physical tools themselves. And this week, The Verge highlighted exactly that dynamic with their Pet Tech Week, looking at the physical devices we bring into our homes to manage our animals.
Pet technology is an excellent microcosm for the broader smart home industry. It really amplifies both the absurdities and the genuine innovation.
Oh, the absurdities were definitely on full display.
Yeah.
My favorite story of the week was a user who decided to completely over-engineer their cat's bathroom habits.
Oh, gosh.
Yeah. So the cats Noodle and Loaf.
Great names. Right. They had a completely normal, low-tech litter box.
Okay.
But the owner installed a motion-activated, glowing neon on-air sign right above it.
You're kidding.
No. It used a motion sensor tied to a smart plug, so whenever a cat stepped in, the neon sign lit up to broadcast to the entire house that the litter box was occupied.
I mean, it is deeply funny, but from an automation standpoint, it is the definition of tech for tech's sake.
Completely.
You're introducing 2 points of failure, a wireless sensor and a smart relay, into a biological process that required zero intervention.
Right.
It consumes power, it clutters the local network traffic, and it solves absolutely no practical problem for the user or the animal.
Exactly.
Yeah.
It's automating just because we have the OPI to do it. But amidst all that noise, there was a genuine hardware solution highlighted this week that actually really impressed me. The MOVA V70 Ultra Robot Vacuum.
Oh, yeah. The V70 is a perfect counterpoint to the AI stumbles we just discussed. It solves a problem with mechanical engineering rather than just trying to write more code.
Because anyone who runs a robot vacuum knows the absolute nightmare that is the kitchen dining table.
Oh, it's the worst.
You have 4 chairs, a table, maybe some bar stools, and the robot approaches this forest of wooden legs, bunks around blindly for like 3 minutes, and then just retreats.
Yep.
It cannot navigate that tight geometry, which is infuriating because directly under the dining table is the exact place where all the crumbs are.
Exactly. And for years, the industry tried to solve this purely with software. They added LiDAR, they added RGB cameras, they updated the pathfinding algorithms in the cloud. But the physical footprint of the robot remained too large to fit between the chair legs.
So MOVA actually engineered a physical solution. The V70 features a mop pad attached to a mechanical arm that extends outward.
Right.
So the main chassis of the robot stays safely on the outside of the chair legs, and it shoots this little arm underneath to reach the tight spaces, sweeping the debris out.
And we really have to appreciate why this took so long to hit the market.
Why is that?
Well, pushing an over-the-air software update to improve pathfinding is virtually free for a manufacturer once the code is written.
Ah, okay.
But adding mechanical actuation, moving arm with servos, managing the increased torque, balancing the center of gravity, and dealing with the massive battery draw of those extra motors, that is incredibly expensive and difficult to engineer.
Yeah, it's fascinating that we threw LiDAR and cloud AI at this problem for 5 years before a manufacturer realized they just needed a stick on a motor.
Serious?
It's like when you drop your keys under the couch. You don't map the room with a laser. You just blindly reach your arm under there and sweep around.
Exactly.
It is durable, practical engineering, identifying a physical limitation and overcoming it with hardware.
And that transition, from the idea of a feature to the physical execution of it on a factory floor, that is exactly where most smart home companies fail.
Right.
Whether you are building a robotic arm or a basic Z-Wave light switch, the software layer means absolutely nothing if the underlying manufacturing protocol is flawed.
Which perfectly sets up the insights published this week by the Z-Wave Alliance.
Yes.
They released a report detailing exactly why so many highly anticipated smart home devices suffer from massive delays, dropped connections, and interoperability bugs. And surprisingly, the root cause isn't bad code.
No, it's not.
It's a lack of protocol fluency at the factory level.
This is a widely misunderstood part of the industry. Most consumers assume an original equipment manufacturer, or OEM, designs a smart plug, sends the CAD files to a contract manufacturer overseas, and a month later, 100,000 units ship out.
Right.
They evaluate these factories strictly on unit economics and volume capacity.
Right, like who can build it the cheapest and the fastest.
Exactly. But for residential automation devices operating on specific protocols like Z-Wave, Zigbee, or Thread, volume isn't the bottleneck. Protocol fluency is.
Protocol fluency, meaning what exactly?
Meaning, does the factory actually understand the specific radio frequency language the device is supposed to speak?
See, I always assumed certification delays were software issues, like waiting on an API to update or a cloud server to provision. But you're saying the bottleneck is actually physical RF calibration at the factory level?
Almost entirely. The Z-Wave Alliance breaks this down into two critical phases: NPI, which is new product introduction, and DFM, design for manufacturability.
Okay.
So if a contract manufacturer treats a Z-Wave routing node like a standard Bluetooth toy, they will miscalculate the power budget. They will route the antenna traces on the printed circuit board incorrectly.
Just to put an analogy on this, it's like trying to print a beautifully written novel, but the printing press itself doesn't understand the physical spacing of the letters.
Right.
The content is technically there, but all the words run together on the page, making the physical book completely useless.
That is highly accurate. If the factory lacks native Z-Wave expertise, they won't flag that the RF antenna is placed 1 millimeter too close to the power supply during that DFM review. So that physical flaw gets baked into the prototype. And because Z-Wave has incredibly strict mandatory interoperability and certification requirements, to ensure mesh network stability, when that flawed device goes to the testing lab, it fails immediately.
Which results in the OEM having to tear down the physical design, adjust the PCB layout, and undergo months of expensive rework.
Exactly.
This explains so much about why a product gets announced at CES in January and doesn't actually ship until November.
Precisely. And this highlights why technical rigor and quality standards are non-negotiable.
Yeah.
The Alliance report heavily emphasized looking for ISO 9001 certification. That proves a factory has rigorous systems to keep manufacturing quality consistent from the first unit to the 10,000th.
And they also highlighted ISO 13485, correct?
Yes. ISO 13485 is paramount if a company is building anything adjacent to health or safety.
Like what?
Like fall detection sensors, elder care monitors, or emergency shutoff valves.
Yeah.
It mandates strict traceability and risk management across the entire supply chain. The report specifically called out CComp, a contract electronics manufacturer with facilities in Mexico and China.
Okay.
They are an active member of the Z-Wave Alliance, and they provide that native protocol expertise directly to North American hardware companies. They engage early in the design phase to dial in the RF engineering and prevent those massive certification failures down the line.
Right. Because if a company couldn't pass certification without a massive delay, you definitely want to know how well that device plays with your existing Zigbee or Z-Wave mesh before you put it in your walls.
Oh, absolutely.
And if you're trying to figure out which devices actually fit your setup, smarthomecompared.com can help you compare smart home products by ecosystem, features, compatibility, and integrations before you buy.
That's a great resource.
Because as we're learning today, you cannot patch a bad physical antenna with a software update. If the RF layout is fundamentally wrong at the factory, that switch is going to drop off your network forever, no matter how many firmware updates the company pushes to it.
Absolutely. The foundational manufacturing dictates the entirety of the user experience. You cannot build a reliable smart home on top of hardware that doesn't fundamentally understand the protocol it's communicating with.
So if we pull all of these threads together, what is the grand takeaway for the smart home landscape this week?
I'd say the overarching theme is the stark contrast between ambient ambition and physical execution.
Okay.
On the software side, the industry is pushing incredibly hard for invisible AI-driven awareness. We see Comcast leveraging Wi-Fi ways to track movement, Amazon expanding LLM access on TVs, and Google trying to force generative AI to map our pets.
But on the flip side, the technology that actually moves the needle for users remains deeply practical hardware.
Exactly. The real wins this week are the MOVA V70, utilizing a mechanical arm to overcome a rigid physical obstacle, and the emphasis on manufacturers like CComp, deeply understanding sub-gigahertz radio frequencies so a Z-Wave mesh network actually stays online.
Yeah.
The durable, mechanically sound ideas are consistently proving more valuable than the short-term software hype.
Which really forces us to redefine what an advanced setup looks like. And I think that leaves us with a final thought to ponder this week.
Let's hear it.
As platforms rush to inject AI into every camera, and ISP routers beg to track the ambient movement of our families, is the ultimate flex of a modern smart home actually building a local, reliable network that actively rejects cloud-dependent gimmicks?
It's a great point.
Like, is true luxury in 2026 having a home that executes its automations flawlessly, entirely offline, just because the hardware foundation is that fundamentally solid?
That is the exact question every serious smart home builder needs to be asking themselves as they evaluate these new platforms.
Something to mull over as you tweak your local automations this weekend. If you found this week's deep dive useful in navigating the smart home landscape, please do us a favor, rate the podcast, and leave a comment on Spotify or Apple Podcasts.
It really helps.
It helps us keep digging into the protocols and the hardware so you don't end up investing in an ecosystem built entirely on hype. We will catch you next week on Smart Home News.